Yeah, so yeah, thanks for having me on. I do want to start my presentation with saying I think I might say a few more controversial things than Chad did, and that's kind of the point. And kind of like Chad said in his disclaimer, we're not, I'm presenting a lot of work that I've done, but also Western Region SSD has, and we're not thinking that this is gospel truth, that the way things will have to be, but it is kind of something that's designed to start conversation about how we can change how we see our jobs and how we operate in the operational forecast realm to do world-class DSS. And primarily, I'm going to be focusing on ensembles. The ensembles, you have a what are the tools and how do I use them? And then you have a how do we need to change our culture so that they actually can be their value can be maximized. I'm going to talk more about the second one today. I'm going to talk to some about the tools, how to use them, but I'm going to talk a lot about kind of how does our perspective on the forecast and how does our culture as a weather service, as an agency, need to change. Okay, so first, this is a slide that we like to show. Text might be a little small, so I apologize if you're squinting. But we like to think, when we talk to Western region, we like to say, like, we need to move to the right. And that doesn't have anything to do with politics. It just simply means that we put some stuff on one side of the slide and some stuff on the other. And on the far left side of the slide is things like using a raw deterministic model or multiple deterministic models. This is kind of the classic or historic way we've operated as an agency. And there's good reasons for that, because we only had a couple deterministic models. And so we didn't have anything else that we could really use. But now that we have large, skillful ensembles and the ability to post-process them and deliver it, we really need to move from the left side, which is kind of the EC and GFS forecasting, to the right side, which is the direction that the MBM is moving. The MBM is still very much a teenager, even a baby in some ways. It's got a long way to go, but the MBM and other things are moving us to the right, where we need to be leveraging the full suite of information that we have. And I could throw 170 models at you and say, okay, give me a forecast. But I think it's better if we let the computer do it, and then we let the human add value where they most add value. So that's kind of the idea. So we need to move from picking winners in an EC and GFS environment to evaluating this post-process and ensemble output, where we can really do what humans do well and let the computer do what a computer does well. And like, why are we doing this? Really, it's because probabilistic information is the only way that we can provide world-class DSS. I'm going to go into more information give you more information as to why I think that's the case later in the presentation. But it's really the case that a deterministic forecast is like looking at the world through a paper towel roll. And we really need to be able to look at the world with two eyes and a neck that swivels, which is what ensembles can do for us. And I have this quote from Ed Lorenz, who hopefully most people have heard of, basically the father of chaos theory and one of the most famous and well-respected atmospheric scientists in history. He was an MIT professor. He said this in 1970. What the critics of probability forecasting fail to recognize, or else are reluctant to acknowledge, is that the forecaster is paid not for exhibiting their skill, but for providing information to the public, and that a probability forecast conveys more information than a simple or deterministic forecast. And this is largely, I would say, and I'm speaking for my experience in Western region, but I think this is true elsewhere most likely, is that forecasters look at like one of their jobs is to look at the EC and the GFS and to pick the winner, to use their knowledge and their experience and their skill to say, this is the scenario that's going to happen. I'm going all in on that one. And really, that's not what we're paid to do. We're paid for providing actionable information to the public. Like a forecast that nobody can make a decision with, or nobody does make a decision with, changes what they would otherwise have done, is worthless. In an economic sense, it's worthless. The ultimate goal is that people make decisions. That's the only way that what we do provides value to anyone. And the best way to make sure that people can make decisions is that they have the information that's critical to answering the question they have, which we can do most effectively with ensemble-powered probabilistic forecasts. Okay, I'm going to show a little bit of a case study. This is from Cristobal, which some of you may remember from back in June. And I've got the EC deterministic and the GFS deterministic for, I think, this is like a 3-day forecast. You can see here in the Florida Panhandle, the EC is almost completely dry, just a few places that might get up to a quarter, whereas the GFS had large areas of 3 inches plus, and some areas reaching up to 6. Huge difference at day 3. And if you were just looking at either of these, really the only choice you would have is to guess. Do you feel lucky? Which one do you want? You can take the average, but really, we don't know what the true range of options is because we only are looking through a paper towel roll at 2 different things. When in reality, we look at the full ensemble suite, we would have 100 different options. The GFS, EC, and Euro ensembles would give us 100 different options for how this might play out. One tool that we really like in Western region that, from what I understand, is getting used elsewhere is the WPC cluster analysis. And this takes a look at the GFS, Canadian, and Euro ensembles and makes a QPF. It clusters them on 500 millibars, and then it gives you the average QPF from each one of those clusters. And even though the actual position of the storm was very similar in each one of these clusters, you can see that over Florida, there's a humongous difference. Like this cluster 2 is exceedingly dry relative to the ensemble mean. And that one was predominantly European ensemble members. This cluster 4 was exceedingly wet compared to the ensemble mean, and that was largely Canadian ensemble members. So the cluster analysis is really showing us, hey, there are some really substantial differences between the different ensembles. So it's reinforcing what we saw in the deterministics. The MBM 90th percentile QPF, here you go. It's like 4 to 5, almost 5 inches in many locations. The MBM median, so this isn't even the 10th percentile, this is the median. In some of those same places was between 1/2 inch and 1.5 inches. The 10th percentile was 0 in most places due to timing and magnitude concerns. Here's a couple weather bell graphics. This is another thing we like. So, WPC clusters are great. The MBM map-based and 1D views for PQPF are great. One thing we really like, when you use a raw ensemble, like to borrow a political term from recently, you need to take raw ensemble data seriously, but not literally. You can glean a lot of information from these plots, but due to resolution issues, especially for us in Western region or for the Western parts of Central region, we can't take it necessarily literally because it doesn't resolve the terrain. But you can see here at this, basically where my cursor is going up and down, like if we had a vertical bar that was all the same color, that would mean really good agreement between ensemble members. But here, the European ensemble, you can see there's a couple heavy members and a huge amount of light ones, and then several that are almost completely dry. At the same time, you can see that the GFS ensemble is exceedingly confident in a really heavy precip, sometimes exceptionally heavy precip. And only a couple of members even get down to just moderate amounts, although the timing is a little bit shifted on those. So it's, we've got a huge range of options for what could happen with precip from Cristobal here. Another way to look at it, this is from the MDM 1D viewer. Looking at 6-hourly PQPF, or sorry, 24-hourly, just basically a 24-hour PQPF forecasts. The 10th, 25th, 50th, 75th, and 90th are in the box and whisker. So the top of this whisker is the 90th percentile. So we have a 10% chance of a basically 5-inch or more rainfall in 24 hours. But you can see here the 25th percentile is almost at the bottom. So we have a 25% chance of getting less than 0.2 of an inch. At the same time, we have a 10% chance of getting 5 inches or more. And when this is the reality, this is the kind of thing where you might look at those 2 deterministic forecasts and you might be able to say, I don't know, or you might say, I'm going all in on one or the other. And so the point of ensembles isn't that they can always resolve the discrepancy, that they can always tell us what the right answer is. What ensembles do is they give us all the information we need to tell all the different people we need to tell what they need to care about with a particular system. Because you can take, if we were making a deterministic forecast from this 24-hour PQPF, when we know there's a 10% chance of 5 inches or more, 25% chance less than 2/10, we could choose the median, which is about 8/10. But what does that really tell you? We could choose the mean, which is probably something close to 1.5 or 2 inches. But what does that tell us? They really the deterministic forecast that you could draw out of this distribution really is probably misleading and even potentially damaging to many partners if we were to message based off that number alone. And even messaging our range might be not be that useful. It's really the ability to message scenarios and the numeric probability of each one of them happening that benefits our partners the most. And social science really supports this idea of the published research, and I'll detail more of that in some future slides. But really, ultimately, it comes down to, what we message depends on the needs of our partners or even the public. We have a deterministic forecast, but really, like I said, the deterministic forecast is kind of like if you bought a house, you want to do all your own, you want to do all your work on your house, you were going to DIY, you're going to do it all yourself. And so you went to the hardware store and you bought a Phillips screwdriver, and you came home and you're like, I can do everything I need to do on this house with this Phillips screwdriver. That's kind of what the deterministic forecast is like. It's the right tool for some jobs, but it's not going to get you very far with most jobs. And the reason you have a toolbox is because if you have all the tools, you can do all the jobs. The ensemble information, the probabilistic information, gives us all the tools to answer all the questions that really give our partners the decision-making information that they need. Okay, so I'm gonna have a few do's and don'ts for the rest of the presentation. Here's the first do. Do ask yourself, what is the most useful forecast? Don't ask yourself, how can I make the right forecast? And this is one that actually comes out of, originally, I saw it in the ECMWF Forecast Users Guide. And this is a fundamental shift that I think historically as an agency, we have focused on making the right forecast. But the right forecast, say for max T, has usually been defined by mean absolute error. I've made the right forecast if I maximize or I minimize the mean absolute error that comes out in the end. But mean absolute error is not necessarily, and often is not, correlated with value to partners to make decisions. And so that's why we need to get out of this idea of making the right forecast and get into the idea of making the most useful forecast. The most useful forecast can often be the thing that is going to blow up your mean absolute error. If somebody really cares about an extreme event, or even something like, fire weather partners who care about chance of wetting rain instead of pop, really, and I'm not saying that the deterministic forecasts we have are not good, or verifying them with mean absolute error is not good, but I think we need to get out of the mindset of making the right forecast to making the most useful forecast. And that is fundamentally dependent upon what the person that you're providing the forecast to needs to do with it. Here's another plot from Cristobal. We could look at this deterministic forecast. You got all the 6-hour precepts and you got the line accumulating them. This is from the MGIM 1D viewer. But really the deterministic forecast is just, it's pulled out of the probabilistic distribution, and it may or may not be the right answer for a lot of people. You can see that down below it, I have the 6-hour PQPF shown corresponding to each one of the deterministic QPFs. And really, in some of these cases, you can see anywhere from a 25% chance of 0 to 3.5 inches. And so if you put 1.8 in to your grids, what does it really mean? Is it valuable? Yes. But when it comes to, say it's WPC or MBM QPF that you're thinking about changing, when the range is that large, even if you double or half your deterministic forecast because you think that'll make it better, the question of whether it will improve your ability to give actionable DSS to your partners is not nearly as clear-cut as maybe, is this going to improve the MAE of my forecast? And for those of you who might get these, this is a Boise Verify email. All the offices in Western region forecasters get sent these. And this is kind of that paper towel roll. this kind of basing fully the quality of our forecasts on a deterministic verification relative to other pieces of guidance is it useful? Yes, but it's still a paper towel roll kind of perspective where we have a very narrow view on the overall value that we're providing to our partners and the public. Okay, here's another one. You aren't busting your 80% pop forecast on a regular basis, you're doing it wrong. And this one goes back to the idea of useful versus right, where, at least speaking for Western region, I know I talked to a lot of forecasters where if they put an 80 pop on day 5 or day 6, they're essentially guaranteeing you, they'll give you their firstborn if it doesn't rain on that day. But really an 80% pop, it's not just okay for it not to rain, it better not rain 20% of the time if you put out an 80% pop. And that's part of the culture, and again, speaking for Western region, that I think needs to shift, where we look at even the probabilistic forecasts we do now, like pop, in a kind of deterministic sense, where like if I put out a 60 pop on day 7, an 80 pop on day 5, or 90 pop on day 2, I'm saying it will rain. But in all those cases, it better not rain, or else your forecast actually isn't that good. It would mean that it was unreliable and less skillful than it otherwise could be if that 80% pop actually did not end up, there being any rain 1 out of 5 times, which is pretty often. Here's another one. Do use numeric values, for instance, 70% to quantify hazards. Don't default to qualitative descriptors, for instance, possible, as they have been shown to result in poor decision making. Now, I have a chart from a Journal of Operational Meteorology paper that was published this year, where they took data. I can't remember, they did not do the data collection themselves. It was a major survey done quite well, where they asked a large sample of people, I think something like 1,000 or 1,500 people, what do you think it means? What percentage chance is expected, or what percentage chance is very low? And you can see the results here, where if we put into DSS or into AFDs or other ways we communicate, words like significant or good or expected, the research shows that essentially we might as well be saying we have no idea what's going to happen in terms, if you look at it from the perspective of what people perceive those terms to mean. You can see that expected can basically mean anything, depending on who the person perceiving it is. There's some bumps near about 75% and about 50%, but I'm guessing most of us would say if we said something was expected, we're thinking like 70, 80, 90, 100%. There's a large portion of people who are, 50% or less is what they're thinking when you say something is expected. And even things like very small or pretty low can be anywhere from 0 to 35% in terms of their perception to many people. And so this is, the social science is almost unambiguous that using a numerical value is actually better at giving somebody the information they need to make a good decision than a qualitative descriptor like possible. And this is just kind of quantifying how big that range of interpretations actually is. So should you always put a 70% in there instead of the word possible? I can't say that absolutely every application you should do it, but it's something that, in terms of moving our culture more in a way that can leverage ensembles well, we do need to move in that direction. Okay, here's another big one, controversially controversial. You need to be a meteorologist in days 1 and 2, but it's better to be a statistician beyond that. Now, this is the one that also comes straight out of the forecast user guide from the ECMWF. And some people might agree with this, but say, well, nobody ever gave me any training in statistics. I took one class where I learned about, means, modes, and medians. There is, like Chad actually mentioned, he and I are both on a team working on providing that training. But really, what this is saying, I'll stay on this slide for a sec. What this is saying is that, things like meso-analysis are and will be critical to the forecast process. That is primarily in the short range, maybe out to day 2. But once we get out to day 3, for almost all forecast variables, and especially once you start getting out to day 6, 7, or beyond, really, you can add more value if you have a really solid statistical background than if you had a meteorological background. And the reason for that is because the uncertainty is so high that really effectively quantifying and communicating the uncertainty inherent in the forecast is much more valuable than being able to dig in and attribute a particular precept to a trowel, or really look at that Q vector divergence in the GFS to elucidate better where the precept is going to be heavy. That stuff can be valuable in the short range, but in the long term, being a statistician is going to get you further faster. Now I think that's a controversial one, and even I have times when I'm like, is that really true? ECMWF's on board with it, and I think as a general rule, it's something that is worth embodying as an agency for us. Okay, and to support that idea, the most important DSS information is probabilistic. Again, from the forecast user guide, but I would have written the same list myself, and us in SSD and Western Region would have. That what we need is the most probable forecasts, which, contrary to popular belief, our deterministic forecasts are often not that. They are often not the most likely, especially for QPF. If your POP is less than 50%, the most likely forecast for QPF is 0. And I would guess that in most offices, when we have a 49 POP, we do not have 0 QPF in our deterministic QPF. So even though we might think we're providing that one, we often are not. Number 2, possible alternative developments. You need an ensemble to be able to do that. Probability of a given event occurring. Again, you need ensemble information for that. Probability that an extreme or hazardous event will occur. You need ensembles for that. Number 5, general consistency without sudden changes from previous advice. Now, obviously, that one's going to apply whether you're in a fully probabilistic or fully deterministic mindset. But we really need to power what we're doing in probabilistic information if we're going to do provide this most valuable information in the most robust manner. And I like this plot because it just kind of shows, what the reality is, where, we often forget that we actually don't really know what the state of the atmosphere is now. And that is due to errors in our ability to observe it and our ability to assimilate that into a model. So, if you look at the European ensemble, it does not know what the actual starting point is. That's actually a PDF. And then things start diverging from there to various scenarios, and you can see that these different scenarios, these blue arrows take, are the ones that we really need to be able to communicate well. Because if you're looking at 2 deterministic models, you might have one go to this top bump, you might have one go to this bottom bump, and you might not have any idea that you've got this middle bump that's the biggest. Okay, just moving quickly to make sure we have some time, a little bit of time for a question or two. Do provide meteorological context with messaging probabilistic information. Don't use jargon. So in a study done in 2008, this was 1,500 members of the public. They had a hypothetical news channel where the vast majority of the public actually preferred one that communicated uncertainty information, not deterministic information. So it's a popular myth that people either don't want or can't use probabilistic information. The social science has strongly debunked both of those. They do want it and they can use it, even if they can't actually explain to you how it works in a technical sense. People actually can use it even when they can't define it accurately, which is encouraging because I bet most people can't define it accurately. And then on the right side, you can see a lot of people do want a deterministic answer. And they actually prefer the range of values, which is this most likely 85, but maybe 70% or 70 Fahrenheit. Will be 85. You get about 35% choose that. Most likely 85, but maybe 70. It's actually less preferable if you just give them that. But if you tell them, hey, it could be 70, it could be 85, but it might be as low as 70 because a cold front's coming through and we don't know when it's going to hit. The preference for that information skyrockets. So it's actually, this is where it's like, you know, we're always going to be meteorologists because we're going to need that context. We're going to provide the context to say, hey, it could snow, we could get no snow, or we could get a foot, because we don't know where the snow band is going to set up yet. That's a lot more valuable than saying could snow, could not snow, might snow, not snow at all, might snow a foot. There you go. You know, the context is important, and for that reason, we will need to remain meteorologists for most lead times, even if statistics might outweigh it beyond day 2. So this is the last thing before the summary slide, which I'll just leave up and not detail. Do make note of MBM successes and failures and post them to the B-Lab forum so that MBM developers can see them. We need to remember the MBM is a teenager. Some of the probabilistic stuff is more of a baby. And so it's still changing. You know, we don't expect teenagers to really have all their crap together, right? You know, they're going to wreck cars, they're going to make stupid decisions. And the MBM is still kind of like that. It can do a lot, but it still is in development. And so giving feedback, especially with context, the where, the when, the why, what did other stuff show, how did we use it, how did we change it, is really, really valuable for MBM development. So that's the last note I wanted to leave you with. And then my summary slide, and I will stop talking there. Thank you.